Chapter 12, it's the end. Here's the review. Last test for 1110. Let's do this thing. So first of all, we need to talk about alkanes, alkenes, alkynes, cyclics. What's saturated, what's not. Well, alkanes are saturated, and some cyclics are saturated. Basically, that means they have single bonds throughout. Okay? Alkenes are a double bond. Alkynes are a triple bond. And cyclics that include a double bond or a triple bond, those are unsaturated. So anytime I have a double, triple bond, I'm unsaturated. When I'm unsaturated, then I can do a lot of different things that can be helpful or not helpful. Now, in cyclics, I can be a cyclic and be saturated because I can just be all single bound. So just remember, single bound, saturated, not single bound, not saturated. Now, you also need to remember that alkenes are not soluble in water, or alkanes or alkynes. They're not soluble in water. They're soluble in a nonpolar solvent. They're less dense in water. As they get small, like 4 carbons or fewer, they're usually a gas. If I get 5 to 17, I'm usually a liquid, and above 17, I'm usually a solid. Okay, so that's important to know. And the more double or triple bonds I have, then the more solid I become sooner. Okay? There was a little bit of misunderstanding as far as when we talked about as the chain gets bigger in alkanes and alkenes and alkynes, its boiling point, its melting point get higher. But as general, alkanes, alkenes, alkynes are low melting points compared to ionic and network covalent. So we need to be careful there. Okay, let's go on. Remember that when we got James Bond, James Bond, we'll win no matter what as far as numbering the chain. So if I take this first chain here and I number it, I want to number it this way because the bond will win even though I've got 2 things coming off number 2 if I numbered the other way. So then I would go about naming and I would say 5,5-dimethyl 2 and 6 is hexene. Okay? Now if I look at the bottom one here, this one is an alkyne, or alkyne. So I'm going to number this way, 1, 2, 3, 4, 5, 6. I'm going to go alphabetical order. So 4-bromo, -5-chloro, -2, now how long is it? 6. It's hexene. Now I can do more than one double bond or triple bond in there. So if you do that, don't forget that right in here you would insert di or tri or tetra depending on how many you had. Okay? But since we don't have that, we're not going to put that in right there. Going forward. So if a molecule is given in condensed form, draw it out before naming it. Don't try and name it when it's all mushed up like this. This is like the textbook company's way to condense it down so they don't have to do so many drawings. So take it and break it up. I don't draw the hydrogens. I draw skeleton form. So I say, oh, there's a carbon attached to a carbon that's attached to a Br. I know Br only can be attached to one thing, so it has to go up. Attached to a carbon, attached to another carbon and another carbon. Then that carbon's attached to a carbon, double bound to another carbon. Now I can name it. It makes life a lot easier. Oh, bond, James Bond. So I'm going to go numbering this way. 1, 2, 3, 4, 5 is my longest chain. I've got 2 methyl groups coming off and 1 bromine group coming off. And so when I go to name this alphabetically, I say 4-bromo, 3-3-dimethyl, and 1, 5 is pent, and ENE. So so I've got the name. So draw it out. Don't try and figure out what it is by not drawing it out. Draw it out, name it, then look for the right answer. Okay, it's not a race to see how fast we can get through the test. It's a race to see how well we can do. So in the next one, when we're naming a double bond, we need to make sure that the double bond is included in the longest chain. Now that doesn't mean that the longest chain is going to include the double bond. So you've got to include the double bond in the biggest chain you can make with the double bond. So I've got this double bond right here, and I want to include it in the chain. So I know I'm going to have to include that ethyl. It looks like an ethyl group up the top. Now, does it matter which way, right or left, I go to the bottom? It doesn't, because either way there's 3 carbons. So I know to get to the double bond, it's going to be easier starting on that ethyl group at the top. I'll get a lower number. So I'm going to start there. 1, 2, 3. Now, which way do I go? It doesn't matter. So I'm going to go to the right, 4, 5, 6. So then I would start to name it. Now, what is this group right here? This group right here is a propyl, right? So off the 3rd carbon, there is a propyl. And off the 2nd carbon, because I have to start where the double bond starts, off the 2nd carbon, there is a double bond, and there's 6 carbons long, so that's hex, and then I put ENE. And that gives me that. All right, so remember cyclics and numbering the bonds before you number the things coming off. So I want the bonds to have the lowest number. So I also look at the things that are attached. So I have got a bromine right here, and I've got a methane right here. So B comes before M, so I'm going to start numbering so the B gets the lowest number, not the M. So I'm going to go like this. 1, 2, 3, 4, 5, 6. So then in naming this, I would go 5 dash bromo dash 6 dash methyl dash, where are my bonds? They're at 1, 3 dash cyclo, and then I've got a hex, and I've got 2 double bonds, so I do di and then put ENE. This one gets a little bit more complicated. So remember to number according to what's coming off. Now, we also can do with double bonds, we can do cis and trans, and we have to be careful. So cis is really easy. When I draw it out, if I end up like this, like a cup, then it's cis. If I end up doing the Egyptian, it's a trans. So this was cis. This is trans. This is not a cis or a trans. And the reason why, and you've got to be careful with this, now look at it, this thing is the same as this thing coming off. So if the same thing is coming off a carbon that is at the end or beginning of a double bond, I can't have a cis and a trans. So be careful with that. Okay, so when I go to name these over here, I would go cis, where's the double bond? 1, 2, 3. And then how long is the chain? It's 6, so hex, E, done. This one would be trans, 3, hex, E. And this one would be what? It would be ethyl, let's see, 1, 2, 3. So I'm going to go 3 ethyl. I'm going to count it this way. Let me count it with you. 1, 2, 3, 4, 5, 6. And I counted that way because I want the double bond to be the lowest, but I also want the thing coming off to be the lowest. So 3 ethyl, 3 hex, ene. Okay? Going forward. Now we got to use Markovniks, however you say that, Mr. Marks, rule, and in addition reactions. Now if we're doing it the same thing, if we're adding the same thing to both sides of a double bond, like the first equation, all we've got to do is just plug it in. So it's going to be HC2Br dash whoops, CH, BR, CH3. Now you know I don't like to write it that way. I like to just go 1, 2, 3. I've got a BR here and a BR here. This is known as skeletal form, so you just know where they're going. Now in the next one, we need to use Markov's rule. Remember, the rich get richer and the poor get poorer when it comes to hydrogen. So if I look at this, this one has 1 hydrogen. This one has 2 hydrogens. So the one on the left, or the one I'm going to underline in the pink, purple, is going to get another hydrogen. So as I'm writing my answer over here, I'm going to get CH3, CHBr, CH3, or 1, 2, 3, with the Br coming off the center. Now as we look at the next one, we want to worry that water will break up into H and OH. So Markov's rule still works, but we're just going to put an OH on the middle carbon instead of the Br. So we get H, OH, CH3, which basically is the same thing, only the OH is off the center. Now notice that we had to add sulfuric acid when we do water because it helps dry it out, is what we call dry it out and split that water up for us. So when we work with water, we usually have to use sulfuric acid as a catalyst. Same thing with hydrogen, we usually have to use platinum as a catalyst. So as we're doing the catalyst there, what we're going to do is we're going to get just CH3, CH2, CH3, just basically propane. Fairly easy. If you have any problems with this, make sure you come and see me. Now we can also do addition reactions when we have triple bonds, but we just need twice as much stuff. Or we can do it when we have more than 1 double bond. We just need more stuff. So as long as we get more stuff, we can just add it in. Markov's rule still applies. So here, the one on the left is going to get the hydrogens. So when I write my product here, I'm going to have CH3, CBr2, CH3. So if I'm looking at it, 1 Br came here and 1 Br came here. All right? Now we need to be able to go backwards. So if I was given the product, I need to be able to say what was my reactant or what did I add to my reactant. Be able to go back and forth, just like we did in your assignment. Now, we've also got what's called aromatic and aliphatic. Okay, aromatic has to have a benzene ring. That makes it aromatic. It must have a benzene ring. That means over here, this has no benzene ring. Makes it pretty easy. So if it's not a benzene ring, it's aliphatic. If it does have a benzene ring, it's aromatic. To name benzene rings, when we have it coming off a chain, we use what's known as phenyl. So this is a phenyl right here. We're going to call it a phenyl. We still have to worry about our chain and about our double bond. So we're going to number this 1, 2, 3, 4. So that's going to be a butene. It's going to be a 4, oh sorry, not 4. It's going to be a 2 butene. And the phenyl is coming off number 4. I got that in my head. Okay, we also have a couple other things. So you need to be able to name a benzene ring, whether things are coming off the benzene ring or the benzene ring's coming off of a chain. If it's coming off of a chain, remember to use the word phenyl. Now, there's also some simple aromatic compounds that you need to look at on table 12.4. These are the nitrile, the NOL, phenol. Look at those because you need to be familiar with them. Put them on your card, okay? Same thing with this ortho, meta, and para. If it's coming off right next to each other, like orthodontist is trying to get teeth right next to each other, it's going to be ortho. If I just met you, I'm going to have a little bit more space than an ortho would be. So I have one in between. If it's para, it's exactly opposite, okay? Remember that carbon can only have 4 bonds. This is really, really, really important. Okay, now there's this funky thing right here. This is naphthalene, okay? Naphthalene is used in mothballs and stuff like that. You'll want to look at that table and sort of become familiar with the more simple ones and what they're used for. All right. So monomers and polymers. This is another chart in your book, table, I believe, 12.3. You need to become just familiar with it enough that you could do this back and forth, monomers and polymers. Okay, so let's take a monomer of polystyrene, which is CH2CH, and then a benzene ring. So that's a monomer of polystyrene. To make, whoops, I forgot the double bond. To make a polymer, we just drop that double bond and say I was going to make a polymer that was 3 units long. So I would just go CH2, CH, benzene ring, CH2, CH, benzene ring, CH2, CH, benzene ring, and another line that went on. Okay? So I can also represent that, if I didn't know how long the chain was, by saying CH2, CH, benzene ring, with an N. Okay? So be able to go back and forth. I can take and look at this and say, oh, this is a 3-polymer ring. This thing right here is repeating. So right here should have been a double bond, and I can go backwards. So make sure you can go backwards and forwards. So don't forget, make your 3x5 card, bring your book, turn it in, pass the test, get your grade up, and we'll see you in class. Sorry it was a little longer than 15 minutes.